Oh, making a video. Yay! Like kind of a weird day though. Weird. Anyway. Yeah, strange. Chemistry. Wish I could model my own chemistry, so modeling is sort of the subject, I think. Holiday Day actually made a video I could tolerate. I mean, I found it listenable, and it was an hour long almost or something. But he's just talking about the generally science. He put spirituality in the title. I don't know exactly why, but he really didn't give that any conversation. But some of these scientific, the premises from which much science operates. Some science operates. Let's say, is not complete. And this conversation comes up a lot about the credibility of science as a source of understanding. And people claim that because science has been wrong in the past, it'll be wrong again. Well, I'd kind of argue that science wasn't really wrong in the past that much. That a lot of religion was disguised as science. I mean, astrology was never a science. Numerology was never a science. So it's really only a fringe of science that has failed. I mean, most science was kind of careful. It didn't draw too many conclusions. When you think about the stuff Newton was playing with, for his time, really quite amazing. Just to be able to experiment. I mean, this is stuff you really had to play with stuff an awful lot, I would think, to even discover some of these phenomenons he extensively wrote upon or pondered. Pondered is probably a good word. He talked out loud, wrote out loud. And again, this is the joke of it. Newton was quite humble in stating his conclusions, his perceptions, his observations, was very careful. And so, in a way, to argue that it was established as fact, and these Newtonians, well, Newton himself was unsure of his model. There was elements that, he conceded the incompleteness of the theory. So, it's very unfair for people to claim, that Newton was wrong. That's, it's just incorrect. Newton was right. The fact that he speculated about some other stuff and did some imagining that wasn't accurate doesn't mean he was wrong fundamentally. Well, anyway, I don't want to get into that argument. Beyond the point that it's not his fault, let me just say it, put it that way maybe, that other scientists weren't as humble as he was, let's say. But regardless, it's a small percentage of the substance of Newton that we've had to modify. So that would be my first argument, is that science is pretty credible over time. The science has really only existed for a very short time. Realistically, we haven't had the instrumentality to do science until fairly recently, the last few hundred years, to do really good stuff. A couple hundred, even. And in that period of time, there's clearly a lot less of a credibility gap. There just is. They don't put the wrong head on the brontosaurus nearly as often nowadays. There's lots of, with more information becomes more capacity to see something that might be wrong or whatever. Well, anyway, this is not where I wanted. Didn't want to waste so much time doing this, making excuses for science's fallibility. It's the modeling thing, and clearly some models are easy. Some things we can spell it out how it works and go through, like a monopoly even. We can model it. We can explain every bit of it almost, except the dice roll maybe, but it's all explainable. You could model the game, even though the game is essentially a model. But I'm just saying you could model the model it gets simpler and simpler as the parts get simpler, and they're a size you can deal with. So the places in science that are most troubling, let's say, for models, I would argue maybe is the modeling of consciousness. The function of our brain is a hard model. I think they're getting the elements of that put together, but I still don't even think we have the vocabulary to accurately describe the elements, so that our standard model of brain function is going to be broken just because our vocabulary is still probably wrong. Words like pain and addiction and desire, and these words are not really, they're good in having conversation about what I'm feeling, but they're not too good as words describing what the brain is doing, because what it's doing might be almost exactly the same for two things we feel very differently. Its mechanics may not appreciate or have built into them the proportionality of the sensation itself, or what happens to us as a feeler, as the experiencer, may not be reflected proportionally in the mechanism. But the idea of modeling the general idea of psychology is now another subject. The Freudian type of modeling the elements of your personality, conditioned versus physical, in the sense of maybe a desire. Some of our desires are innate, hunger, for example. What exactly you desire is conditioned like a sexual preference, and that's mutable, through experience and conditioning, habit, tradition, it's probably a better word, routine, something like that, imprinting kind of a thing. Part of us is imprinted, and part of us is innately constructed to do a certain thing, a certain way, no deviations allowed, blah, 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 blah. Of course.
Hi, how you doing?
Okay.
Ready for the winner.
Another one anyway. Happy horse people. Anyway, where was I? Really having a little, I don't know what this is, like a blood sugar thing right at the moment. Yeah, it's always something. Yeah, the wheels. The wheels. But they're wheels. They really are real wheels. Okay, wrong way to put it. There are real mechanical, functional hormones, chemistry, glands, things producing the effect that becomes our disposition, and there is real electrical storage in our neurology holding, our personality. These are real things. They follow there are real patterns of function, rules, laws, however you want to describe those, regarding how what chemical does what thing to what organ or which receptor. These are all, it's all real events. And it can be modeled, but it's very complex, so it's very hard to model. Then we got into this physics thing, Dale was talking about, and here the difficulty is we don't have a model. We have observed outcomes, and through mathematical functions like quantum mechanics, it's possible to duplicate, predict outcomes based on incomes. So you have an incoming circumstance, and because you have studied outcomes and you realize there's this probability circumstance that exists, that there's a variance in interaction, and that the variance has a mathematical function. It's not a mystery. It's not magical. It's not unreliable. No, it's consistent based on a probability. And once you establish the medium and a couple other factors, you just plug in the math and do the math, and it'll tell you how the system's going to work. Because you'll have identified the variables relevant to the working, relevant to the end product and its deviation. And so the model is the math in the sense that you have a function that'll doesn't show how it works. It just works it. It runs it through. It works the model without the image of the model. I don't know how to, it's a shortcut. Just like you don't need a real lever to model the function of a lever to understand the force dynamics and to know exactly how much weight you need to put on what end to lift so much weight. You can know all that ahead of time with math, and you don't need to have the image of the lever to do the math. But it certainly helps. I guess that's what I'm trying to get to, is that the model keeps the train on the tracks. I mean, having some of the visual elements, the mechanical elements, understanding the mechanical elements, having a model of them is very helpful in terms of understanding, where, not only validating and verifying, what you have as mathematical outcomes, but it gives you a platform to, draw more expansive conclusions. In and of itself, it just elucidates, it just makes it understandable, cognizable. It helps to be able to, use a lever to understand a lever. And it would be helpful to be able to ride a light beam. It would be helpful to be able to understand more, in a more visceral, mechanical way, what exactly is taking place in the exchanges, in the interactions between these very small particles, very small entities, we could call them. It doesn't really matter whether a photon is a thing or a blob or a widget or a whatnot. The point is that it is a foundational function. It holds the constant, which is the speed of light, and that's the important thing mechanically. I would argue there's nothing else going on except stuff moving at the speed of light, I would say, in my understanding. The model I think I can construct into a valid, coherent model to the facts is one that basically states that it is a checkerboard. It is a very simple thing at its core, and there's just so much of it that it's gotten complex merely because it has very simple functions, but it is massive scale. And the massive scale means a ton of monkeys have connected to each other in very elaborate ways to create very eccentric kind of forms, and those forms create new force effects. But it's all built on a very simple dynamic at its core, and the complexity is only in volume. The complexity is only achieved through the volume of permutations and the volume, just the mass, the amount of discrete elements interacting. The number of interactions, I guess, would be another way to say it. Yeah, I mean, hopefully they mentioned the Susskind guy and the holographic universe crap and the information thing, which is kind of I mean, it's kind of obvious once you have E equals mc squared, and once you have the theory that, energy cannot be created or destroyed. You've already stated that information can't be created or destroyed, because all information is a interaction, an energy interaction. So how can you possibly destroy the information of the interaction when the interaction requires an uncoupling mechanism? It requires it's nothing in the mechanism can be undone without releasing what was done. A better way to say that. It's not like the way out is always as complicated as the way in. But yeah, but in a way it is. The unraveling will release. That's still not the right way to say it. Well, I'll wait till I have the right way to say it. I'll come back to that one. But it is sort of obvious, like I said, that information involves interaction. It can't be stored, can't be contemplated, can't be anything without swirly bits banging into each other. So it's always information is created energetically. I guess that's the point. And so therefore the information of the creation is in the fact of the creation. I guess that's a better way to say it. That doesn't look bad. Reset all those. Anyway, until next time. Such cool. Thanks for your pleasure. Yeah. Anyway, until next time.